For example 1, I want to solve this inequality graphically. So I'll do that by graphing both lines. So we have y is equal to 2x minus 3. So I'll start there. Let's see, negative 3 is the y-intercept. The slope is positive 2, so we go over 1 and up 2. Again, I just need a basic sketch. It doesn't have to be perfect, but I get a line that looks something like this. And for my second line, that is y is equal to, 4x plus 1. So that has a y-intercept of 1 and a slope of 4. So I'll go over 1 and up 4. And my line goes through these 2 points. So it increases like this. It drops down like this. And I see that the two graphs actually meet. They intersect. Kind of looks like it's maybe around -2. Again, my graph isn't like a perfect sketch, but the next goal is after you graph your two lines is to figure out, well, what is that intersection point? So let's see. I'll let 2x minus 3 equal 4x plus 1. I want to solve this for x. I guess I'll do this by, I'll subtract 4x from both sides. So I get -2x minus 3 is equal to 1. And then I'll add 3 to both sides. So I get -2x is equal to 4. Okay, I see that this is right, that if I divide both sides by -2, I do get x is equal to -2. That is the x value where the two graphs intersected. So my sketch wasn't so bad. But the actual question is, well, where is 2x minus 3 greater than or equal to 4x plus 1? So like, where is it above the other equation? So if you want to do this graphically, here we called y is equal to 2x minus 3. That's the blue line. I want to know where's the blue line above the green line. It's actually easy to see on the picture. If I focus on the green line, like if I choose a spot around here, well, this green line is actually above the blue line. So I know it can't be here, but if you look past the intersection point to the left, so like here's the blue line, and it is above the green line. So I've actually identified on my graph, okay, it's this portion here. It's this part of the graph where the blue line, it's greater than or equal to, the blue line is greater than or equal to the green line. To answer the question, you have to tell me the x values where that happens. Well, -2 is definitely where they're equal. And if you go to the left, it's all of these x values where the blue line is greater than the green line. So to answer the question from the graph, so you look at the graph, you ask where is one equation above the other, you identify the x values, and the x values go from -infinity up to -2 and including it, and that's the answer to this part of the question. For example 2, I want to solve 2x minus 3 is greater than or equal to 4x plus 1. The same from example 1, but I don't want to use a graph this time. I just want to do it by hand, analytically. So I'm going to copy down the equation again. So we have 2x minus 3. Where is that greater than or equal to 4x plus 1? And we can solve this just like we would an equation. I did put this note within the question. If you multiply or divide an inequality by a negative number, it's going to change the direction of the inequality. So it's just one thing to be careful about. So to solve this inequality, I'm going to start by subtracting 4x from both sides. And we get -2x minus 3 is greater than or equal to 1. Now I'm going to add 3 to both sides, and so we get -2x is greater than or equal to 4. So this is looking like what we did in example 1. And now I'm going to divide both sides by the number in front of x to isolate x. and that number is -2. So I'm dividing both sides by a negative number. So it does cancel to give you x, and we do get -2 on the right side, but it's no longer greater than or equal to, it's actually less than or equal to. Said another way, that's everything from -infinity to -2, which is the same answer that we got in example 1. To quickly see what's going on here, if I take just two numbers, like -3 is less than 7, so that's definitely a true statement. If you were to divide both sides of this expression by -1, the numbers that you get would be now a +3 and a -7, but it can't be less than anymore. It has to be greater than for this to make sense. So in essence, what we're doing here is a shortcut. If you multiply or divide both sides by a negative number, it would have to flip the inequality. For the last example, I just wanted to look at a more complicated inequality, something that wasn't as easy as just two basic linear functions. And again, we can solve this just like we would solving an equation, just being careful about multiplying or dividing both sides by a negative number. So here we have 1/3 times x plus 7 minus 2. Where's that less than or equal to 1/9? And then we have 5x minus 4. So I think a decent approach for this problem would be to multiply both sides by 9. It'll cancel both denominators of 3 and 9. So I'll just make note that there's a least common denominator of 9. So I'm going to multiply that to both sides. It's a positive number, so it won't change the direction of the inequality. So I'm going to take each term and multiply it by 3. So I'll just say like, okay, we're putting a times 3 here. Or sorry, it should be, that's not correct. It should be 9 multiplied to every single term. So maybe just as a note. When I first multiply by 9, the 9 1/3 gives me 3, and I have x plus 7. Then I have minus 2 times 9, which is 18. Then I still have less than or equal to. 9 times 1/9 is just 1. I won't even write it. And we're left with 5x minus 4. We don't need the parentheses because there's only a 1 inside of it. So again, just kind of continuing like we would with a linear equation, I'll distribute the 3 into the parentheses, and we have 3x plus 21 minus 18 is less than or equal to 5x minus 4. Okay, maybe now I'll simplify both sides. So I have 3x, that's going to be plus 3 is less than or equal to 5x minus 4. So I guess now I could subtract 3x from both sides, but maybe just to look at this whole idea of dividing by a negative, I'm going to subtract 5x from both sides. And at the same time, we could actually just subtract 3 as well. Since this is doing the same thing to both sides, we get negative 2x again. We still have less than or equal to. And on the right, we're going to have negative 7. So now to get our final answer, again, we're just dividing by that value in front of our x, which is negative 2. It cancels. We get a positive 7/2, but now it's going to be greater than or equal to.